Hello? I think you can hear me, right? So, my name is Fiorenzo LENZI, and today I'm going to give you a presentation regarding some innovative multifunctional composites for different applications. So in my presentation, I will go from the industrial part to the transportation part, and I will hope you enjoy this journey through various applications in our industry and in composites in general. So first of all, I'm going to present a little bit our company and highlights the role that multifunctionality has in our company, but in general in the composite industry. And then I will go through some examples of multifunctional materials, but not just showing some properties, also going through various applications that will include the aerospace part, the automotive part, and the industrial application. So I will give you some example of fire retardancy, so how fire retardant material can be used in some application, then examples of thermal conductivity and how we can actually work on this material to have products for different markets, and an example of magnetic properties. But before entering into this topic, let me spend a few words about the company in general. So VonRoll today is part of the Altana group, a group which counts about 7,000 people, and he had turnover of about 3 billion in 2020, and is divided in 4 different divisions. One division is BYK, which is global market leader for additives and for measurement and testing equipment. Another is Eckhart, which is leader in coating systems, in graphic arts, in cosmetics, personal cares. Then we have the Elantas group, that today is worldwide leader for primary isolation system and secondary isolation systems, going from resin system to engineering materials and composites, and Actega, that is leading the flexible packaging part, the paper and board application. So when we really focus inside VonRoll group, then we can really identify 3 different main product segments. One product segment is for the electrical insulation. So here we speak about Mica and systems for the high voltage application. Then we have one product segment which includes fundamentally resins for electrical protection and in general for isolations of different systems, which may be electronics or electrical system, and the engineering materials or the composite material works. And today I'm really focusing on the composite material part, which is really the core of this show here. So how we work on the composite material? So the first thing, we operated at all levels of the supply chain. So we go from the formulations part to the end application, really developing different materials in the entire supply chain. So actually we can offer pre-preg material, we can offer sheets, we can offer machined parts and tubes. And we do this thanks to our know-how and also on the fact that we can supply materials for different markets. For sure, right now with an high focus on the large application, large-scale application, like for example, automotive, aerospace on the e-mobility market. So the topic of today is really about multifunctionality. And I want to give a vision of this topic that is not just about material properties, because we really think that multifunctionality means ability of deliver a material into the market that not only has certain specific performance that are the ones that are essential for the application, but they can also meet several other targets. So this target may be of, for example, compatibility with the environment, maybe sustainability. So maybe fundamentally make sure that the product is suitable for the customer and can be easy adopted by the industry, but also by the general society and environment. And of course, we have different applications for this case. So I'm going to show you some specific cases today. For sure, for us, we have three fundamental pillars we are focusing. One is the formulation know-how, which is essential to achieve some multifunctional characteristic. Sustainability is really at the core of any development we have. And last but not least, fundamentally is to try to integrate all the function in one product, which means fundamentally to simplify bill of material, allows really the customer to have an easy use of the product. And this can be at the level of handling, like increasing or changing tack, viscosity, adhesion, or maybe at the level of reactivity, for example. And we have different cases. I'm just going through some cases today with you. One example is for sure the aerospace part, where we combine performance. Performance means, for example, in this case, fire retardancy with environmental compatibility, which is the sustainability topic, with the fact that the customer experience is improved with product with much better reactivity, which comes at the level of simplification and really at the level of an approach to integrate different materials. So first case I have today is really the aerospace part. And I think that the aerospace, especially, let me say, in the last years, I had more and more focus on the fire retardancy part. So maybe a lot of you, I hope they have listened to one of the big fire events that happened in Japan at the beginning of this year, where there was an A350 that actually crashed a very small turboprop on the land, and this caused a very big fire accident. So this was so huge that was probably recognized as one of the most severe fire accidents that the aviation has experienced in the last decades, but likely all the 379 passengers were able to evacuate the plane, and no people died. So, of course, this is an impressive case of how important is multifunctionality in composite, and in this specific case, how important is the fire resistance capability of some materials. So in VonRoll, we have been looking in the last years to several different products for the cabin interiors part. And if we look at all these products, then we see that always in common we have products which need to have very good self-extinguishing characteristic, products that are able to reduce the smoke emission, products that they are very low in toxic gas emission, and somehow they satisfy all the flammability requirements. This can include, for example, some inserts which are in composites used for fixing the seats on the cargo lining, material which may be, for example, electrical panels, resins for potting, fire resistance material for the burn-through protection of the fuselage, and a series of pre-preg material that all need to satisfy some severe fire requirement. So when it comes to this work, I'm proud also to show one example of one of the key innovations we have been made in the last years that was not obvious because it's a special materials that was never really used for such application, but it was finding in the fire resistance really the key value proposition for a new product. And that is a product which we call the Mica Fireproof. So this is a product that fundamentally is Mica. Mica is a silica material, a phyllosilicate material which is impregnated with high temperature resistant silicon. And this material can resist to about 1,200 degrees. It has the key advantage of let me say, merging the sustainability targets that we have, for example, the use of natural resources, with the possibility to achieve very high performance. And in fact, this is a product which is extracted from the land and is transformed in a product which is safety relevant for the aviation industry. And is a product that even at 0.1 millimeter thickness, it has so good fire barrier characteristic that actually can survive very severe fire scenario, like the one for the FER 25853 part 3 or part 7. You see some picture of mines into this chart, and this is because in our company what we do, we extract from mines this mica material, and we transform it into flakes, which are sorted, and then they are transformed in a paper. A paper which is fundamentally 100% inorganic product, which is then laminated and impregnated with resins. And then this is transformed in a product which is suitable for this application. And it's really impressive, I think, to see how we can really make use of natural product, fundamentally a rock, in something which is so very important for the community in general, for all the passengers traveling all around the world. So the other example I want to give you today is about prepreg. This is also another topic that has been recurring, discussing and focusing by many prepreg manufacturers in the last years. And fundamentally, the topic is how we can actually try to improve one of the very traditional prepreg which is used for cabin interiors, which are phenolics, in something which is more sustainable. So this product has one key advantage, which is the flammability part, but it comes with a lot of drawback. So it contains phenol, formaldehyde, so this is toxic and cancerogenic. It's a product that cures in a quite long time, which is more than 1 hour and a half. It has very limited shelf life, so it needs to have a -18 storage condition. It comes with fundamentally low mechanical performance, and also it releases some volatiles at the point where also the surface quality of the parts is not satisfying the general customer expectation, at the point that a lot of rework needs to be done. So what we have been doing here was to start from this flammability performance and try to develop a replacement for this product with something which is an epoxy material, an FST, so a fire retardant epoxy system, which of course satisfies still the same flammability requirements, but has many advantages in terms of sustainability, so no anhydride, no halogen, no solvent, fast curing, which is key benefits in terms of affordability, no volatiles, much higher mechanical performance, and in addition the fact that because this system does not contain any solvents, there is nothing which is released during curing. So the surface quality of the part is significant better. And I think this was, let's say, 2 examples that I wanted to bring you today about the role, for example, of the fire retardancy into the aerospace world. Let me go to another examples of multifunctional materials, which is about thermal conductivity. And also I'm going to bring you few examples, one which is one case of a very low thermal conducting material, and another which is a case for a very high thermal conducting material in 2 different applications. So for the first case, I want to bring the case of the automotive industry. I think if you go around this at the JEC, maybe you find 20 or 30 stands where this topic is really one of the key focus for the composite industry. And of course, VonRoll is following this trend by developing materials which are designed to be used for current and next generation battery protection. So here the topic is how we can solve or mitigate the risk of lithium-ion batteries going in fire and going in thermal runaway. And this today relies on the material development part, relies on composites, and relies on the ability to have some composite material that have very low thermal conductivity. So why this is important because we need to isolate each single cell to prevent thermal runaway, and then fundamentally to prevent that from one battery going in fires, also the other are consecutively having the same product. Very challenging topic, because although this seems to be a very simple material, we need to use this approach to integration in having a material that has actually very versatile multifunctional characteristic. So how we did this? Fundamentally, we combine mica material, which can be used for fire protection, fire resistance, and as a material for breakdown voltage resistance, with an aerogel material inside. So to develop fundamentally a sandwich structure that combines from one side the fire retardant and fire barrier part, and on the other side the low thermal conductivity. And if you look at the graph, which shows basically how this material is changing thermal conductivity as function of the temperature, you see that always this stays at the level of B, maximum 0.1 watt per meter Kelvin, which is a level of thermal conductivity which allows really to prevent or even to stop completely the thermal runaway for batteries. So another example's completely different field, but I wanted to pick up this just to show how multifunctional can be used really for very versatile application, is for medicines. So maybe, I don't think everyone in this audience knows that an MRI scanner, which is used for controlling the human body, is actually have a lot of composite parts into these constructions. And the composite are used here to give some mechanical reinforcement to the scanner, but here really they need to have some very high thermal conductivity in order to dissipate all the heat and energy which is released during the service of this material. So in this case, we have to develop a very high quality material that can be used under control and environmental conditions, because this is for medicine application. And we managed to develop one product which is called the Vetronit EGS 619 HT, so high thermal conductivity. And this material is today widely used into the market and for the construction of these scanners as one of the material that allows fundamentally to dissipate very quickly the heat generated during the operation and basically improve the efficiency or durability of the scanners. So last examples that I want to show you today is about magnetic properties. Also completely another field, another application. And then we are going into this case into the wind energy field. So we start from the aerospace, then we went to automotive, industrial, and this is a case for the wind. So if you look at the wind turbine and you focus really on the motor part, then into the motor part we have of course the rotor and the stator, and there is essential the use of some composite material which I use as slot wedge. So the slot wedges are material which fundamentally I use into the construction of the stator to keep and to maintain all the copper wires which are traveling inside this construction. So the main issue of this industry is that in order to keep continuously the rotation of the rotor, this creates some electromagnetic field, And this electromagnetic field is creating some air flux into the gap between the rotor and the stator. So the challenge is how we can actually counter-react or to balance this electromagnetic field so that does not create any problems in the acceleration of the rotor. And what we discover is that actually we can play on the magnetic characteristic of this composite part. And by playing with magnetic part, we can actually change the electromagnetic field which is around this part. And this is improving a lot the speed of the machine, so basically the efficiency of the motor. How we did this? So we started from an high functionality epoxy system, so very high mechanical resistance at high temperature, and we fill this material with high concentration of iron power in order to increase as much as possible the relative permeability of this material, which is about 3 at 0.5 Tesla. And at that level of magnetic characteristic, this product really allows to improve the efficiency of the motors by about 10%. And that, I think, was another case how we can actually work on the multifunctional material to create something which is more sustainable, which allows for reducing energy consumption and somehow goes into direction to have a more green environment and applications for these motors. And with that, I finish. So I thank you a lot for listening me. I have 2 minutes. If anyone has any question, I'm happy to take them. Or otherwise, you can visit us at in this hall. We are at the booth F79. Thank you very much.